this video is on matter classification and how we take certain types of matter and further classify it into pure substances, mixtures, elements, compounds, things like that. So to start this discussion, we'll be using a flow chart today. This is the same flow chart that you should have. It's the easiest way, in my opinion, to discuss this classification of matter. So the first question we have to talk about is, well, what is matter? Okay, what is the definition of matter? And some of you might already know. The definition of matter is anything that has mass and takes up space. And taking up space is the act of having a volume. Okay, and from math class, you probably know you can calculate the volume of a cube, a cylinder, all those types of shapes. If it's in a regular shape, we've talked about that already in our discussion on density. Okay, so matter, to be matter, two things. It has to have mass and it has to take up space. So basically, everything you think of is matter. Okay, so we'll start with some, very simple examples. Things like your pencil, your water bottle. Okay, all those things have mass and take up space. The harder discussion is, well, what's not matter? And that's a little bit of a difficult one to think about. So maybe off to the side, we'll try to come up with a few ideas that are not matter. Okay, this is a little bit hard. A lot of students will ask the question of air. Okay, well, is air matter? And so this is actually something we're going to come back to with a little demonstration in class. So we'll kind of leave that as an open-ended question at the moment. But in terms of what's not matter, there are a couple big things that are not matter. They don't have mass and they don't take up space. Things like light, heat, sound. Okay, those things don't have mass and they don't take up space. So that's a little bit of the harder discussion, is not naming things that are matter, but naming things that are not matter. And again, this whole question of air, we will come back to after our demonstration in class. Some of you might know the answer, but I think the demo is the best way to discuss that. So once we've identified something as matter, we then further ask the question of, can it be separated physically? And by physically, we mean lots of physical separation techniques, things like picking something apart, things like using a filter, straining something, boiling something. So there are lots of separation techniques, and we'll talk about those later. But physically, meaning, can you and I go back into the lab and take this mixture, take this piece of matter apart? If the answer to that question is yes, then the matter is further classified as a mixture. So I'm going to go back up to my examples of matter and add in salt water. Okay, so is salt water matter? Yes, absolutely. It has mass and it takes up space. Can we separate salt water physically? Well, I hope you know that the answer to that question is yes. And we would be able to separate salt water into salt and water by boiling it, right? Heat it up, boil the water, evaporate the water, and you'd be left with salt. And so that's a physical separation technique. So because we are able to separate salt water, we can further classify salt water as not only matter, but also as a mixture. And a mixture is technically defined as a physical blend of two or more substances. I don't know if I want to use the word substances. No, I will. That's okay. Okay, so a physical blend of two or more substances. Now, salt water has only two things, salt and water, but there are mixtures that can have more than two things. So an example, of course, is what we're talking about, which is salt water. Kool-Aid is actually a mixture, right? How do you make Kool-Aid? Water, sugar, the Kool-Aid packet, which is the flavoring and the dye. Okay, it's a mixture. That's definitely more than two things. And then sometimes we talk about food in this chapter, which is kind of funny because, it's not really chemistry, but, so I always like to add in, like trail mix. I don't know if you guys eat trail mix, but trail mix is, sometimes it has raisins and nuts donuts and M&Ms and all those types of things. It's definitely a mixture. It's a physical blend of more than two things. Okay, so once we've identified something as a mixture, then we ask one more question, which is the composition the same throughout? And composition means what it's made of. Okay, so let's go back to salt water, for example, or even Kool-Aid, either of those two. If you had a container of salt water and it was stirred thoroughly, okay, then that saltwater mixture would be the same at the top of the container as it is at the bottom of the container. Same can be said for Kool-Aid as long as you've stirred it. The top of the Kool-Aid mixture is the same as the bottom of the Kool-Aid mixture. So, and to answer this question, is the composition the same? For those two examples, the answer would be yes. And that would allow us to further classify this type of mixture as a homogeneous mixture. Okay, so homo means same. And all this means is that the mixture is the same throughout. Okay, so our salt water, our Kool-Aid, our homogeneous mixture. Some people say homogeneous, that's okay. But homo means the same. So homogeneous, same throughout. Now, if we go back up to my discussion of trail mix being a mixture, trail mix is most definitely a mixture, but is the composition the same throughout? I think in this case you'd have to answer no, because if you got a handful of trail mix from a bowl and then your friend got a handful of trail mix from the bowl, they would contain different numbers of the different components. And so the question of is the composition the same, the answer would be no, and this would classify as a heterogeneous mixture, and hetero means different. So all a heterogeneous mixture is one that is different throughout. Now, let me add in my example of trail mix. Okay, now you might be able to argue that salt water, if you just dumped salt in a glass of water, that right at that moment in time, it would be heterogeneous, and I can definitely understand that because the salt would sink to the bottom and it's just water on the top. But assuming that we had evenly stirred the salt water mixture, that's why we said it was homogeneous. So hopefully that clears up any questions that you may have had. Okay, so let's go back to the top of my notes and back to talking about matter. Remember, has mass and takes up space. And we want to ask ourselves the question of now, can it be separated physically? So let's go to something like gold. Okay, so we all know gold has mass and takes up space. And so now our question is, can we separate gold physically? Well, the answer is no. There's nothing you can do to take gold and break it apart. So because that's the case, gold is not classified as a mixture, but it's classified as a pure substance. Okay, so the definition of a pure substance is one with a fixed composition and the same throughout. So we said gold was an example. I'm going to go ahead and put another example in here because I want to talk about this. All right, so gold has a fixed composition. That means gold is always made the same, and it's the same throughout, meaning it is homogeneous. Now notice I didn't say homogeneous mixture, because see, something can be homogeneous but not be a mixture, so that can be a little bit confusing. A better example to talk about in this case would be water. Right, we know that water has a chemical formula. Its chemical formula is H2O, right? That means it takes 2 hydrogens and 1 oxygen to make water. And that's true all the time. It doesn't matter if you're in West Virginia, if you're in Maine, if you're in Florida, water is H2O. So one interesting thing about a pure substance, and you might want to add this, are that pure substances have chemical formulas. Okay, pure substances have chemical formulas. Mixtures do not. So that's a very big difference between pure substances and mixtures. So now you might ask, well, what's the chemical formula for gold? And we're going to get to that in just a minute. All right, so from here, after we've identified something as a pure substance, now we ask the question of, can we chemically separate it? Okay, and the answer is either yes or no. So if we talk about something like water, okay, H2O, water is made of hydrogen and oxygen. So can we physically separate water? If we go to the lab and boil water, we don't physically separate it. We just change it from a liquid to a gas. But could a chemist use some kind of chemical means to separate the hydrogen from the oxygen? See, it's chemically separate. So could we do some kind of chemical reaction? And you might not know that the answer to this question is actually yes. A chemist can. It's called electrolysis, and we will discuss electrolysis in class. So if the answer to this question is yes, a chemist could break down this pure substance, then the pure substance is classified as a compound. If the answer to that question of can we physically separate something is no, which would be the answer if this was gold. Okay, so if we're talking about gold, can a chemist chemically separate gold? The answer is no. And the reason the answer is no is because gold is an element. And an element is the simplest form of matter. I'm going to expand this definition just a little bit to say the simplest form of matter that remains unchanged in a reaction. Okay, we'll talk about that later when we talk about chemical reactions. So what are your examples of elements? Well, everything that's on the periodic table, right? Because it is in fact the periodic table of elements. So everything on the table is an element. So gold, right? And remember when we talked about, well, what's gold's chemical formula? Well, it's just its symbol, which is Au from the table. So gold is an element, oxygen is an element, carbon is an element, lithium is an element, right? We could go on and on. There's in fact 118 of them. So elements are the simplest form of matter, basically, that we're